In addition to understanding the Arduino hardware we'll be working with, there are a few other components which we need to comprehend before we can start building circuits and prototyping. Breadboards, shields, and printed circuit boards are all fundamental pieces of hardware that help us create circuits and are integral to building Arduino projects. This tutorial will explain these three pieces of hardware, their function, and how they interface with our Arduinos. Breadboards, which we see here, act as a platform that can easily connect various components in order to facilitate the building of an electronic circuit. Breadboards are extremely convenient to use when prototyping or testing circuits because components can quickly be plugged in and a circuit created without permanently soldering parts together. There are several sizes of breadboards, but all of them function the same way. Breadboards consist of tiny holes in which the leads of components plug into. For example, if we have an LED, we can plug the positive and negative wires into any of these sockets. These tiny holes are connected underneath the board by metal clips called terminal strips. These clips allow current to flow from one point of the strip to the other. In a small breadboard, the terminal strip runs horizontally to the center line, and thus any current always runs this way. This is the same for the half-size or large-size breadboards, but in addition to these terminal strips, larger breadboards also have power rails. In these larger breadboards, power rails are located on each side of the terminal strip. Power rails are like the terminal strips, but the flow of current runs the length of the board. These rails are meant for positive and negative power supplies. For a helpful visualization of the flow of current through the breadboard, if we go to the Fritzing program and click on any of the pinholes, we can see the flow of current through that component. Now that we understand how the flow of current works within breadboards, we can see that circuits can easily be built by placing components on the breadboard and connecting them together with jumper wires. When a path is formed by wires and components from the positive supply node to the negative supply node and power given to the circuit, current flows through the path and the circuit comes alive. When prototyping and testing circuits, we use breadboards because there is no soldering required and thus the circuits are not permanent and can easily be manipulated. But sometimes we may want to use or create more permanent circuits that cannot easily be changed. To do this, we can use something called a prototyping shield. In the Arduino language, shields are printed circuit boards that can be plugged on top of the Arduino to extend its capabilities. Various shields have different functions, such as connecting to Wi-Fi networks, extending audio capabilities, and integrating LCD displays or cameras. That's just to name a few. These shields are stackable and plug on top of the Arduino board, drawing power and all the programmable function from the Arduino headers below. Depending on the board and its function, some shields will connect to every pin on the Arduino, or only use a couple of the pins. A prototyping shield is like the rest of the shields and plugs directly into the Arduino board. But the shield has no predetermined function. Rather, it acts as a breadboard that allows you to design and make custom circuits. The center of the prototyping shield contains a series of pinholes where you're able to insert components and connect wires like a breadboard, but these components must be soldered on for the shield to work. By soldering parts to the prototyping area, we can quickly create custom circuits that are secure and permanent so that we can attach and remove the shield from our Arduino board without having to constantly recreate our project. The layout of prototyping shields will vary depending on the manufacturer that makes them, but in general, the pinholes beside the headers will have the same function. There is usually an area of pinholes for power and ground at the top, and at the center of the board are the pinholes for the components. As I briefly mentioned before, which I'll explain in more detail now, shields and even Arduinos use printed circuit boards, or more commonly called PCBs, to hold physical components. A printed circuit board is the base plate of most components and shields that, if you look closely, have lines and pads which connect various points on the board together. These lines are traces that have been designed to allow electrical current to be routed through the paths to connect various physical components that are placed on the board. When we are prototyping various circuits either on a breadboard or prototyping shield, we are connecting components and completing our circuits with wires. A PCB eliminates the messiness of the wires by embedding the connections or the wires within a board and providing plated through holes where components can then be soldered on to create the final circuit. For most of our applications, especially when we are continually testing and experimenting with microcontrollers, using a breadboard or prototyping shield to create our circuits would suffice. For advanced users and those who are looking to create a customized shield for a complex project, we can design our own PCBs using the Fritzing program. Although I will not go into detail in this tutorial on how to create your own PCB, I would like to show you that in the Fritzing program, you can create your own circuit in the breadboard view, which we have already done, and then switch to the PCB view to customize your own board. This view allows you to choose which board shape or size you want your PCB to be made for, place the location of components, and modify the tracing and connection between components. In addition, there are several options about the board characteristics which can be changed before exporting the file to send to a manufacturer to create your PCB. If you would like to learn more about how this process works, the Fritzing website is a great resource with instructions on how to create your own printed circuit board. So that's all for this tutorial. You should now have a good knowledge of the functions and interfaces of breadboards, shields, and printed circuit boards.